Hey, welcome. Today, we're basically going to be detectives. And our big case? Planet Earth. Now, look, we all know it's a sphere, but this isn't about what we know. It's about how we figured it out. We're going to piece together all the clues that people gathered over centuries to solve one of the greatest mysteries of all time. All right, let's get into it.
So let's just start with the big question. For a really long time, the whole flat Earth idea kind of made sense if you just looked around. But what you see isn't always the whole story, right? So what evidence could you, just you, standing on the ground, find to prove that the world is actually round? That's where our investigation begins.
So our first stop is going to be simple, everyday observations. The earliest clues weren't discovered in some fancy lab or with a high-tech telescope. Nope, they were found by people who were just paying attention to the world around them. Okay, I want you to picture this. You're standing on the beach, watching a big ship with tall masts sail out to sea. What do you actually see happen? Does the whole ship just kind of shrink into a tiny little dot before it vanishes completely? Think about that for a sec, because the answer is actually one of the oldest and coolest proofs for a round Earth.
And this visual right here, it nails it. See, if the Earth were flat, the whole ship would just get smaller and smaller. But that's not what happens, is it? We see the hull, the bottom of the ship, disappear first. Then the deck slips out of view, and the very last thing you see is the tip of the mast. This bottom-up vanishing act can only happen if the ship is going over a curved surface.
Okay, so a ship proves the curve over a huge ocean, but could you actually spot that same curve over a shorter distance that looks totally flat? Well, a really clever experiment in England decided to put this to the test.
This was called the Bedford Level Experiment. The setup was actually pretty simple. They took 3 poles, all the exact same height, and stuck them in the ground a few kilometers apart along a really long, straight canal. Now, if the Earth were flat, all 3 tops should have lined up perfectly, but they didn't. When you look from one end, that middle pole always looked a little bit higher than the other 2. And why is that? Because it was sitting on the highest point of the Earth's curve between the 2 ends. It's a brilliant, measurable proof of the curve.
And then, of course, you've got the ultimate physical proof, sailing all the way around the world. In 1519, Magellan's fleet took off. 3 years later, one of his ships, the Victoria, made it back to the starting point without ever turning around. And that's the key takeaway, right? You can only sail in one continuous direction and end up back where you started if you're on a sphere. It was just undeniable, real-world proof.
So we've collected all this evidence from right here on the ground. Now let's level up our investigation. It's time to look up at the sky, because the cosmos holds even more clues about the shape of our world.
Let's talk about the pole star, also known as Polaris. If you were standing at the North Pole, it would be directly over your head, a perfect 90-degree angle. But as you travel south, say towards the equator, you'd watch it get lower and lower in the sky, until it's right on the horizon. This steady change in the star's position is only possible if you are moving along a curve. On a flat Earth, Polaris would look like it was at the same angle no matter where you were standing.
All right, here's another cosmic clue for you. A lunar eclipse, right? That's when the Earth moves directly between the sun and the moon, and our planet casts a big shadow on the moon's surface. So what can that shadow tell us? This is just brilliant. It doesn't matter how the Earth is spinning or what time of night the eclipse happens. The shadow our planet casts on the moon is always an arc. It's always a piece of a perfect circle. I mean, think about it. There's only one 3-dimensional shape that casts a perfectly circular shadow from any angle, and that's a sphere. A flat disk? It would cast a thin line or an oval sometimes. But Earth's shadow is always curved. So all these clues, the ships, the stars, the shadows, they all built a pretty airtight case. But in the 20th century, we finally got the smoking gun. The one piece of evidence that nobody could possibly argue with. And there it is. The first actual photographs of Earth taken from space. For the very first time in human history, we could finally see our planet not just as an idea proven by clever experiments, but as it truly is, this beautiful blue sphere just hanging there in the dark. So, mystery solved. The Earth is a sphere. But, solving one mystery just opens up an even deeper one. What makes this particular sphere so special? Why is it this vibrant, living world when our cosmic neighbors are basically just barren, hostile rocks? Well, for starters, it's the temperature. Earth's average temperature is a pretty comfy 17 degrees Celsius. We're in what scientists call the Goldilocks zone. We're not too hot like Venus, not too cold like Mars. It is just right.
And that temperature is perfect for liquid water to exist, which, as we know, is the foundation for all life.
And speaking of water, about 70% of our planet's surface is covered in it. This massive global ocean is absolutely essential. It helps control our climate by soaking up huge amounts of heat, which stops us from having wild temperature swings. You can think of it as our planet's built-in thermostat.
And then, of course, there's the very air we breathe. Our atmosphere is this perfectly mixed, protective blanket of gas. Yeah, it's mostly nitrogen, but it's that crucial 21% oxygen that allows us and pretty much all other animals to live. And this specific mix doesn't just let us breathe. It's also a shield, protecting us from nasty solar radiation and trapping just enough heat to keep the whole planet warm.
But here's the thing. It's not just about having the right ingredients. The real magic of Earth is how all those ingredients work together. Our planet isn't just a rock in a really good neighborhood. It's a living, breathing, interconnected system.
Scientists have a name for this zone of life: the biosphere. It's not some separate place. It's the overlap, that thin, precious layer where the air, the land, and the water all meet and interact with each other. It's basically the stage where all of life happens.
And this diagram shows it perfectly. You've got the atmosphere, that's the air. The lithosphere, that's the solid ground. And the hydrosphere, that's all the water. Life, all of it, thrives right there in the middle where these three systems intersect, constantly exchanging energy and materials. Each part needs the others to work.
And inside this biosphere, everything is connected through cycles. Just take the nutrition cycle. Energy from the sun gets soaked up by plants. Animals come along and eat the plants. Other animals eat them, and when they all eventually die, decomposers break them down and return all those nutrients to the soil for new plants to use. It's this incredible, continuous loop of energy that just keeps going.
And the same thing is true for the actual building blocks of life itself, like carbon. As you can see here, carbon is in constant motion. It moves from the air into plants, it travels up the food chain, it gets breathed back out, and it's stored in the oceans and in the earth. This constant circulation is what keeps the entire system in a delicate balance.
So let's just wrap this all up. We've seen how simple observations, cosmic clues, and finally, a picture from space proved our world is a sphere. But maybe more importantly, we've seen that it's an incredibly special sphere, one that's in a Goldilocks zone with liquid water, a perfect atmosphere, and all of these complex, self-regulating cycles working together. It's a finely tuned living system. And that brings us to our final and most important question. Knowing all this, what's our part in keeping that delicate balance?